about me. So I've got 15 plus years of networking experience. I'm mostly into training and development field, guys. My key technical areas are multiple over here. So routing and switching, service provider, data center, security, design, wireless, cloud computing, and virtualization. I talk multi-vendor products. So Cisco is of course, my pioneer product. Apart from Cisco, I have got other uh, vendors as well, which I usually train and I am knowledgeable with. Certification wise, I have attended and attained a lot of certifications in my career. The list is over here. The premium ones are being CCI. I'm a VMware VCP. I'm a VMware VCI, which is a VMware certified instructor. Um, I'm also CCSI. I'm a Cisco certified system instructor. Plus, there are other certifications which I've cleared.
Welcome. We are doing IP services, that is HSRP, VRRP, GLBP. I'll have some quick points for that. So the topic is IP services, HSRP, VRRP, GLBP, which we frequently use in our industry. And the major reason of using those protocols is to provide something called as gateway, or I can say the reason why we use this IP services based protocol. It's to offer something called as default gateway redundancy, right? This is the major reason why we use this particular technology called as IP services. All right. Now, what I'm doing is I'm going to have a lab setup for this. So this is the topology what we'll be using for IP services. And I'll discuss first, what is IP services all about, and each protocol one by one, and then we'll do the lab with this particular scenario. All right. Now, talking about IP service for the first thing. Now, you have got one protocol suite called as FHRP. Okay. So FHRP stands for First Hop Redundancy Protocol. Okay. So under this particular suite, you have got three protocols, which is inside them. So one of them is HSRP, next is your VRRP, and next is your GLBP. Okay, full form wise, HSRP stands for Hot Standby Router Protocol. VRRP stands for Virtual Router Redundancy Protocol, and GLBP stands for Gateway Load Balancing Protocol. Okay. Now, these three protocols, they come under this umbrella called as FHRP. Now, FHRP itself is not a protocol. Okay. The protocol is basically all these three: HSRP, VRRP, GLBP, which works under FHRP. All right. FHRP is a concept. So the concept is to offer default gateway redundancy to your LAN users. Okay. So I've got a scenario which is made in Eve, and you can see that I've got, couple of, or let us say 4 hosts. I've got a router. I can convert this router as a host. I've got some LAN users. Okay. You can see that. And they're plugged to a LAN switch. And this particular switch is connected to 2 upstream routers, right? The reason I've connected 2 upstream routers is to offer, for redundancy reason, right? If one of the router fails to reach to the uplink world, then I will have this other router to, offer this redundancy as a solution, right? So what the LAN user normally does, right? If you think about, LAN users concept, if you think about any sort of LAN user, what they will do is they will have something called as default gateway. So you give them an IP address from their respective subnet. So the subnet that I'm using is a private subnet over here, which is 192.168.1.0. From there, let's say the IP address is, .1, the IP is, .2, etc., etc. Just a second, let me, as I was telling, this LAN network is the private LAN, which is 192.168.1.0/24. From there, I've got some users sitting in the LAN. So let's say I'll convert this router to work as a host. So let us say his IP is, .1, his IP is .2, .3, and .4 respectively. Now the whole idea is, what happens is if this particular user wants to reach to your outside world, so I've got, two routers as an uplink router, via which it can reach to the outside world. And let us say R4 is that ISP router, okay, that is connecting two links, one link to R1, one link to R2. These are all your public, IPs that you can see here. And I'm assuming that these are some public internet IPs, 1.1, 2.2, right? So these users want to reach those public internet. Now, the users to reach to the public internet, they will use something called as, default gateway, right? So they will be using something called as default gateway, because if the user want to reach anywhere outside of its own LAN network, the default gateway, let us say the user has set, it can be either for R1 or can be either for R2, right? So you can imagine that, okay, let us say the users are getting the IP addresses from DHCP, from a DHCP server. I can configure the DHCP server to offer him an IP address automatically from this particular subnet. And also I can say the default gateway to be either as .100 or .200. Now the problem is if I configure the default gateway to be, let us say 192.168.1.100. Now what will happen is this user traffic will actually be handled via R1, right? What if R1 fails? Or what if this particular E00 interface connecting to the LAN, it fails? In that case, I have to manually go to all these users and change the default gateway from 100 to, .200, which is really a difficult task. I mean, it's not a practical task in the production world, right? You cannot actually go and manually change the default gateway, and it does not happen over time. I mean, the router has failed just now. You cannot go and manually say to all the routers, to all the users that, hey, your default gateway has to be changed to that from 100 to .200, right? It's a very, very difficult task to manage. That's the reason we offer something called as this IP services based protocol called as HSRP, VRRP, and GLBP. The major reason of using this protocol is to offer something called as default gateway redundancy, right? So what we'll do is we'll actually group this R1 and R2, the LAN interfaces. So basically we'll group this particular, my LAN interfaces, and we would run this protocol HSRP, VRRP, GLBP on this particular LAN side. Okay, so now you can say that R1 and R2 will be part of HSRP group. Okay, and we would actually HSRP protocol would actually send hello packets to each other. Okay, and find out their HSRP neighbors, and HSRP will decide, we have to configure one virtual IP here. So 1.150 as the virtual IP. So this virtual IP will be actually handled by both the routers, right? So HSRP would run on R1, HSRP would run on R2 in the same group. The group ID is important. So let's say I run HSRP. So in HSRP, what I'll do is I will say, hey, both of you, you're running HSRP, and say the group ID is group ID number 1. In the group ID, what happens is I will define something called as a virtual IP. Okay, and the virtual IP I'll set as 192.168.1.150. Now what I'll do is I will let this LAN users to use this as the default gateway, not the physical IP of the router. So I'll go to the LAN users and I will say, hey, your default gateway is not, your default gateway is not this, you're not 200. So I can actually, cancel that. And I can say that your default gateway IP is now 192.168.1.150. All right. So what will happen now is when you configure HSRP, let us say in this case, with the case of HSRP, what happens is we have some concept, right? So we have got concept like one of the router will be elected as a active router, and the other router is elected as the standby router. So let's say this router becomes the active router for HSRP, and this router becomes the standby router for HSRP. Okay. So what will happen is whichever router is the active router, that interface will be routing the LAN user traffic. So all this user traffic would be actually routed by the active router interface to the outside world. All right. Now, if the active router fails, what happens is we have got in the same HSRP group another router, which is R2. Now this standby will actually become active if the primary active router, if it fails, right? I mean that active interface if it fails. All right. So this is the most important thing. That means automatically the users during this LAN interface failure, the users should not change their default gateway IPs. The default gateway IP remains the same as .150. Now, whichever is the active router, he will be providing the default gateway service as a redundant way. And what will happen is, the traffic will be, routed via whichever interface is the active interface of that particular router. All right. That is the idea of, any protocol, HSRP, VRRP, or GLBP. All right. Now, considering that, you have to think, there are multiple scenarios by which you can actually work it out. So first of all, I will talk about, there are 3 protocols as I've discussed, and we'll do a comparison of those 3 protocols first. Okay. Now let's take the notepad, or let's do one thing. Let's draw a comparison over here. Okay. So if, let us say, if I say about, protocol features, let us say I've got something called as features, right? And let us say I've got protocol as HSRP, I've got protocol as VRRP, and a protocol as GLBP, right? Let's see what are the features we have. So if I talk about something called as scope, right? So if I see HSRP, so HSRP is basically, it is Cisco proprietary protocol. It is developed by Cisco, it is run by Cisco, and supported only on Cisco devices. Okay. If it is VRRP, it is actually IEEE standard. So it is open standard basically. So any devices, any vendors, you can run VRRP protocol. And even GLBP is Cisco proprietary protocol. Okay. Now regarding something called as load balancing, I'll say LB. Okay, load balancing. Now load balancing is not supported technically with HSRP or with VRRP. It is not supported, but with GLBP, it is supported. Now, what is the meaning of load balancing? It's a very simple thing. So for example, let us say, at a given point of time, I've got 2 routers over here, right? One of the router would be active, one of the router would be standby, right? For HSRP, for VRRP, we call that name as master and backup, right? So one of the router is master, one of the router is backup. If I have, we can have, 4 routers maximum in the group, right? So let us say if I have 4 routers, I think maximum is 16. So we can have 16 routers in the group. But what happens is one of the router out of those will be active or will be master as per HSRP or VRRP, and remaining everything would be standby or backup, right? So 2 routers cannot be active at given point of time, or 2 routers cannot be master at any given point of time. So whichever is the active router, so that active interface would be routing the user traffic to the outside world. That's the reason, load balancing is not actually there, right? So both the routers are not, actively supporting load balancing. So some user traffic R1 is handling, some user traffic R2 is handling. That is not available with HSRP or VRRP. We have some interesting solutions to do that. Like we can actually have multi groups and all those things. We can do that, but real load balancing is not there. But with GLBP case, it is there. In GLBP, what happens is, in case of GLBP, 2 routers can actively forward your user traffic, right? And that name in GLBP, it is called as, AVF, right? We have a name called as Active Virtual Forwarder. I'll discuss that when the time comes. But the name is Active Virtual Forwarder. So 2 routers in the group can be called as the Active Virtual Forwarder. Now, with AVF, what happens is, let us say the first router, the first LAN user, if it is willing to go out, then his traffic is handled via R1. The second user is trying to go out, his traffic is handled via R2. Third user is trying to go out, his traffic is handled via R1 again. And fourth one is handled via R2 again, right? So we'll have active kind of load balancing, or think like round robin based load balancing by default with GLBP. Okay, that's the reason it is called as load balancing is supported here, but load balancing is not supported there with HSRP or VRRP. Okay, now there is something called as multicast address. So the multicast address is important. So they actually communicates when you run HSRP or enable HSRP, VRRP, or GLBP on the LAN interface of the router facing towards the LAN. They would send hello packets to each other, and the hello packets would be sent using multicast IP address. And the multicast address for HSRP, it is 224.0.0.2, which is basically in case of HSRP version 1. Okay, and you have another version of HSRP, which is version 2. In that case, it is 224.0.0.12. Sorry, 102. 0.0.102. Okay, this is in case of version 2 of HSRP. All right, and in case of your VRRP, The multicast address is 224.0.0.18. And in case of GLBP, the multicast address is again 224.0.0.102. Okay, so using this multicast IP, they actually communicate between this HSRP group of routers, or VRRP group of routers or GLBP group of routers. So between themselves, they will talk to each other using this control plane called as hello packets, and the multicast IP is set to those values. And one more important thing is they work, all of them actually work for UDP. So the transport protocol is basically UDP, and the port number for UDP is going to be UDP. For HSRP, it is UDP 1985. In case of VRRP, it is UDP 112. In case of GLBP, that number is UDP 3222. Now it's very important, because if, let us say, between the HSRP routers and the LAN, we've got a firewall sitting here. Okay, so the user's traffic is first of all hit to the firewall. From the firewall, it will go to the routers, probably. If the firewall is the L2 firewall or whatever, in that particular case, make sure the firewall we have to configure and make sure these ports are open. Otherwise, they will not be able to talk, right? And we have something called as virtual MAC address, virtual MAC concept. Okay, so I'll discuss that. So the MAC address value for HSRP starts with 0000 0C07 .AC followed by XX, where XX is basically the group number, right? So if your group number is HSRP1, so it is AC01. Okay, that's the virtual MAC, and the value starts with those. In case of VRRP, the virtual MAC starts with 0000 5E 5E00.01XX, where XX is again the VRRP group number, whatever you set. And in case of GLBP, it is 0007 dot B4 XX XXXX. Okay, so this is again the group number, but it has got higher values for that. So the thing is, this is what virtual MAC is, because when you configure virtual IP in either HSRP, VRRP, or GLBP, the virtual IP will have a virtual MAC inside it for the ARP, right? So if this user wants to do an ARP for the default gateway, so basically they'll be actually resolving the MAC address of the default gateway, and the MAC address, what the users will be getting is the virtual MAC, and the virtual IP will contain that virtual MAC based on whatever protocols you are setting up. Okay, IPv6 support. So do they support IPv6 or not? So it is supported by HSRP, it is not supported by VRRP, and it is supported by GLBP. So if in case your LAN is running with IPv6 address and you want to offer default gateway redundancy, you cannot go with VRRP with IPv6. It is supported with only HSRP and GLBP to be notified. All right. Now, as I've told you regarding election criteria, so what happens with HSRP is one of the router would be active, one of the router would be standby. If we have let us say 4 routers in the group, one is active and rest everybody is standby. Okay, so how it depends? It depends on something called as a priority value. It depends on something called as a priority value in case HSRP. In case actually all, the first criteria is basically priority value, and the default priority is 100. The default value is 100. So the election criteria is basically happens based on the priority value. The default value is 100. So every interface will have a default value of 100 here. So this interface will have a value of 100. This interface will have a value of 100. The LAN interface, I mean, which is actually, common for all the 3 protocols. Okay. Now what happens is, if the priority is tie, then what happens is the highest IP address becomes the winner. Okay. So whichever IP is the highest, so .200 will be the winner, he'll be the active, and whichever is the lowest IP, he'll be the standby. But actually this happens again on first come first serve basis. So within 10 seconds, what happens is we have got a hello timer of 1 second in case of HSRP, and a dead interval of 10 seconds. So basically, if you go to R1 first and you configure HSRP on E00, and within 10 seconds no one has joined in the group, what happens is R1 will claim this interface as the active, and whichever comes later in the group, they will be all be standby, just like that. Okay, so the whole idea is one is active, one is standby, remaining everybody who joins in the group, they will be all standby. and whichever is the active router, he will be holding the default gateway. I mean, he'll be holding the responsibility of forwarding the user traffic to the outside world. Okay, and all these routers in the group will actually be responsible for managing the default gateway in the cluster. You can say that, and the virtual IP will have the virtual MAC address alongside with it. Okay, so basically the concept is, in case of HSRP, we use a term as active and standby. In case of VRRP, we use the term as master and backup. In case of GLBP, we use the term as active virtual gateway, that is AVG, and AVF. I'll talk about that in a moment. Hold on for that. Okay, we talk the term as AVG and AVF, active virtual gateway and active virtual forwarder. Okay, these are the terms that we normally use. So which is the active router, which is the master router, which is the AVG router. So those things happen based on priority value. Default priority value is 100. Or if you want to make manually, one of the router interface as the active or as master or as AVG, in that case you have to go with the highest priority value. So let us say I want to make R1 as the active manually. Okay, so what I'll do is I will go and configure R1 with a value of say 120. Okay, and others will have a value of 100. So this interface will be the active interface because it's got the highest priority. All right, so highest priority always wins. Remember that. Now regarding timers, okay, let me close that. Regarding timers, so for HSRP, I'll talk about timers. For HSRP, the hello time is basically 3 seconds, and the dead or the waiting interval, we normally say hold time. The hold time is basically 10 seconds, right? So if two routers are in HSRP group, they're not able to see the hellos to each other for 10 seconds, then only they will do the election criteria. They will re-elect the active router. Okay. So in case of VRRP, the timer is basically, we have got 1 second as the hello time, and we have got, it's like quite 3 seconds for the hold down time. Okay. In case of GLBP is again the same like HSRP, it is hello time is 3 seconds and the hold down time is 10 seconds. But if you want, you can manually reduce it to 1 second and 3 seconds. So probably you can see that the relation is basically 3 times the hello time. So you can actually lower the value of your choice. You can lower the timers for quick election and for quick response, right? So in that case, you can make the hello to be lowest as 1 second. Okay, and the dead to be lowest as, or the hold down to be lowest as 3 seconds. Manually, you can go and change the value so that if let us say the active interface fails, so within 3 seconds, the other one becomes active, and the users don't have to wait for 10 seconds for the default gateway to be active and the traffic to be, in operation. Right, I think this is clear. Now, there is another important topic called as, preemption. Let's discuss preemption. So what is the meaning of preemption? Okay. So the topic is preemption. So very, very important topic. So in case of preemption, so what is the meaning of preemption? Preemption means, let us say, if R1, I'm running HSRP, let us say, in case of that, R1 is the active router. He is the active router, and he is the standby router. Okay, R2 is a standby router. Now what happens is, due to some good or bad reason, this active interface has failed, right? So R1E00 has failed. So if R1E00 fails, what happens is now this active would actually transit itself to, so active will become now standby. Within that, that timer, right? Once the timer expires, you will see that active became standby, and the standby will, be elected as the new active router. This will become the new active router. Okay. Now, by default, in case of HSRP, if you run HSRP, by default, preemption is disabled. Okay, very, very important. By default, in case of HSRP, preemption is, this feature of preemption is disabled. What does it mean? It means if now the failed active interface, if it regains the role, then will it become active again? Will it actually, the failed interface comes back online, right? If this particular interface, comes back online, if it is good now, will it become automatically active? Will it transit itself to active from standby? And will this transit from active to standby? Will that happen? The answer is no. The answer is no, right? So whichever interface, that transition, the retransition won't happen if preemption is disabled. So it is always a good idea, because you might think that, okay, I've got an uplink, which is basically, let us say it's a 10 Gbps uplink that is connected to R1. Okay, and I've got an uplink which is, say, very slow, say it is like 2 Gbps uplink connected to R2. Now you would always want that R1 should be the active interface always, right? Because your uplink is having higher bandwidth. So in that case, if you disable preemption, it's not a good idea. It is always recommended to enable preemption in all the three cases of HSRP, VRRP, or GLBP, right? So manually we have to go and enable this particular preemption feature, so that if the failed active interface returns or regains the role, then that transition happens from standby to active. Okay. Now, in case of VRRP, preemption is by default enabled. Okay, so it is by default enabled. And in case of GLBP, again, preemption is by default disabled. So it is always a good idea to enable preemption, not to disable that, so that, as per your choice, whichever router you wanted to make active, he would return to the role if the interface has failed and it regains that particular interface. Okay, I've discussed regarding this router roles. I've told you, in case of HSRP, one router is called as active, others are called as standby. Basically, this is the role. Example, let me write it down. So I've got roles for you. For HSRP, we use the terms like active. One of the router is active in the group. One of the router would be the standby. The second best router is standby, and remaining all the router would be in this stage called as the listening stage. Okay, so if let us say I've got 4 routers in the group, so what will happen is one is active, one is standby. Okay, and rest everybody is in the listening stage. So if in the HSRP group you have got 4 routers, one is active, one is standby, whichever is highest one became active. The second best is the standby, and the rest everybody is in the listening stage. In case of VRRP, one is master and rest everybody is backup. So you've got 4 routers, one is master, rest 3 are backup. In case of VP, you have got 1024 routers. You can keep 1024 routers in the group, out of which what will happen is one router would be called as AVG, a virtual gateway, right? And rest all would be called as AVF, active virtual forwarder. And I'll discuss that how it works. Hold on for that. Okay, that is the role names what you get in case of HSRP, GLBP, and VRRP respectively. So first of all, I'll start from, let us say, from the way bottom. So I've got this router to be converted as a host. So what I'll do is, just give it a sec. The host name, say it is a whatever, host 1. Okay, to convert the router as a host, the command is basically no IP routing, turn off the routing services. So it will work like a end device. Okay, and you can go to the interface, like I'm going to the NIC card and giving an IP address here, saying no shut, and the IP address as per the plan is 192.168.1.1, and the mask is as per /24. Okay, and I can give him a default gateway now. I can say command is IP default gateway, and my default gateway is, as per the concept, it will not be .100 or .200, it will be .150. So I'll set the default gateway to be .150, which is the virtual IP address. So 192.168.1.150. Done. So similarly, what I'll do is I'll go to these VPCs. Okay, I'll configure their default gateways as well. So I'll give the command as IP, which is 192.168.1.2. 24, and the default gateway is 192.168.1.150. Good. If I do show IP, I can see that the IP is .2, the default gateway is 150 over here. Looks good to me. The next PC over here, I'll say IP is 192.168.1.3/24, 192.168.1.150 as the default gateway. Good. If I do show IP, I can see the IP is .3 and default gateway is 150 here. Likewise, I'll go to the last PC. I'll say the IP is 192.168.1.4. And this is 192.168.1.150. So everybody is pointing to the default gateway as the 150, which is the virtual IP address for my FHRP protocols. And if I do show IP again to verify, the IP is taken as .4 and the default gateway set as .150. All good. Switch, I want to keep every interface in VLAN number 1. So no point of configuring the switch. By default, everybody is in VLAN number 1 because I'm taking only one subnet here. Okay, let's go to R1 now. And what I'll do is, naturally, what you'll normally configure is you'll configure the LAN interface and the WAN interface IP, respectively. Okay, for both the routers, the LAN interface and the WAN interface IP. And then via the uplink, you'll normally configure what a default gateway. So via this direction, you'll be configuring a default route. Via this direction, you'll configure a default route to reach to the world of internet. Okay, or towards the ISP. Through the ISP next hop, you will configure a default route to reach to the world of internet. And what the ISP router will do is, I'm not doing NAT here just to make things quite simple. So if I don't do NAT, then the ISP router should point something called as a static route to reach to this particular LAN subnet. Okay, so I'll configure something called as a default route here. I'll configure a default route here, and I'll configure a static route to reach my LAN subnet from the ISP to the LAN network. Okay, if I'm not doing that, or we can run some sort of IGPs to make things happen, but IGPs generally do not run between the ISP to the edge router. That's the reason I'm not going to configure IGPs here. But if you want to make it simple, you can just run any IGP like ERGRP or OSPF, for example, between R1, R2, R4, and make sure these networks are converged. Okay, but I'm going to do like a real one. So if I'm not doing with BGP, if I'm not going with NAT, in that case, let's have a default route that points towards my ISP router next hop, and the ISP router points the static route to reach my LAN network. Okay, so let's go to R1 and keep that in mind, and let's configure that. So I'll go to R1 and I'll say I'll configure two IPs on R1 and R2, and likewise I would go and configure the default routes here. This is my R1. Okay, I have this interface E00 that's pointing towards my LAN. So the IP address over here is 192.168.1.100, and the mask is the physical IP of the interface. The WAN interface is E0/1 connecting my ISP, and the IP address is 14.1.1.1, let's say. Mask is /24, and I'll configure a default route as per the plan. So all 0 in the field, all 0 in the mask, and I'll say my next hop is basically my ISP router, which I'll configure the IP as 14.1.1.4. So that is R4. Okay, that's it. So two IPs on the LAN and the WAN interface, and one default route towards the ISP as the next hop. Okay, done with that. Similarly, I'll go to R2. So in R2, we'll have the respective configurations here. This is R2 over here. I'll have an interface, which is the LAN E00. I'll say no shut. I'll say 192.168.1.200. And that's IP double add, double D. Okay. And the WAN interface is C0/1. And the IP address over here is 24.1.1.2. Okay. And as per the plan, I'll configure a default route towards that ISP again. So IP route 0000, all 0 in the mask. And my next hop is 24.1.1.4, which is R4 as the ISP. And with this case, I'll go to the ISP router now. So ISP router, I'll assume that two loopbacks as my internet, IPs, might be some resource of the internet, say facebook.com, google.com, whatever. So this is host name, let's say it's ISP router. Okay. And in that case, I've got a couple of loopbacks here representing my internet addresses. So that's 1.1.1.1 in /24. And I've got another loopback to say this. And I've got the two interface connecting my company's edge router. So it is interface E00. As per the plan, the IP address over here, it will be 14.1.1.4. And over this side, it is E0/1. So the IP address over here, it will be 24.1.1.4 as per the plan. And don't forget, we have to add a static route to reach my LAN network. So through both the sides, I'm going to add. So IP route, which is 192.168.1.0. So this ISP router knows how to reach my LAN network. We have both the side, which is 14.1.1.1 VRR1 as well as via 24.1.1.2. Okay. I believe I went to R2 and gave the IP as 24.1.1.2 here. Yes. Okay. So I can go to R4. So I can configure equal cost multipath or ECMP based static route to reach my LAN network. If I see my routing table now, show IP route, basically the static routes, you can figure it out that you have got two equal routes to reach your LAN network via R1. Okay. Now the users, won't be able to reach your internet now. The reason because the default gateway is .150 and we have not configured, the HSRP or any solutions for an FHRP yet. So the default gateway is not yet running on the routers, right? That's your basic topology that you have configured here. So let's go and run the HSRP commands right now. So we would configure first HSRP here. So what I'm going to do is I'm going to bring R1 and R2's LAN interface. So this two LAN interface will be part of your HSRP group number, say group number 1. Okay, and then we'll follow the commands. So first thing first is basically we'll go to R1. So I'm on R1 here. Okay. So whenever you configure HSRP, what happens is you have to go inside the interface. Always go into the LAN interface and configure this FHRP protocols. Do not go to the WAN interface. Always go to the LAN interface and configure the HSRP protocol. So go to interface, which is E0/0, and then you can give a command. Now the command is not HSRP. Okay. For VRRP and for GLBP, the command starts with the respective names as VRRP and GLBP. But for HSRP, it is quite strange. The command is standby. Okay. So basically, when you use the command called as standby, it means you're running HSRP. Okay. So it's like standby 1, which is the group ID here. And then you can define something called as a virtual IP, which is 192.168.1.150. So just to begin with, this is the only command that you need. But we have got other commands as well that you can give, right? Just to begin with. And right now what will happen is this router will wait for 10 seconds so that it will find out that, okay, on this interface, do I have any others claiming that they are an HSRP? If not, then this router itself or this interface will become the active router. Okay. Let's go to R2 and R2 also in the LAN interface, which is interface E0/0. Give the command as standby. Make sure we go with the same group number. That's very important. Standby 1, same group number. So two routers in the same group, then only they can participate. If they're in different group, then they will not be able to communicate. Okay. So standby group ID is 1. Then give the virtual IP, which is again the same 192.168.1.150. So both the routers in HSRP group number 1, it is maintaining this particular virtual IP. And the virtual MAC will be automatically calculated and it will be assigned to this particular virtual IP. Okay. So if you notice now, if I go to R1, you can see that, this interface became active, right? This is a message here that may 00. Initially it was standby and I'm switching this to active because within 10 seconds, I didn't find anyone joining here. And if you verify that, the command is actually show standby. Okay. Command is show standby. So basically, it is show HSRP, but the command is standby over here. Instead of the word HSRP, the command is, or the word is standby. Okay. So show standby. It is group number 1 is running on E00. The state is active over here. This router or this interface is the active interface. And you can see that the virtual MAC, what is assigned here as per the discussion, the virtual MAC is this AC01 and the virtual IP is this, and it is running with version 1 by default. Okay. Hello time, hold time is 3 and 10 seconds by default. Preemption is by default disabled, as I've told you, and the active router is local. This is the local router, and right now standby router is unknown. Priority is 100 by default, and the default is 100. Okay, and I can see the group name, so it auto elects a group name for its interface. If I do show standby again, all right. So now what happens is I'll go to R2. Let's say if I look here, if I do show standby, there is an issue here. So here even E0/0 is claiming that I'm the active. So here actually both the routers are claiming that they are active. Might be I've got an issue with the switch. Waiting for the next hello to go. So they're sending and receiving hellos. It should say that the state is actually standby. Here the state is active. Here also state is active, which is not the correct thing. I'll just toggle the interface. Interface E00 over here. Set it shut down. I'll also go to this interface. This interface E0/0 over here and say shut down. I'll just bring the interface to be up. I'll bring the interface to be up. And let's see what happens now. Show standby. Yeah, the state is listen. On R2, show standby. So R2 is active here, and R1. Now that's not the correct thing, because both of them, they're claiming that they are active in the same group. In the same group, it's not the correct thing. Can I ping it? Let me go and say 192.168.1.200. Works. That's strange. Let me see if I'm sending and receiving the hello packet. It's on UDP 1985. So you can see that source is 200. The issue is I'm not able to see the hello packet from the other side. So I can see that I'm sending everything from my source IP. The hellos are going out, but I'm unable to receive the hellos here from .100. Okay. If I go to R1, if I do the same thing over here, debug IP packet details. I'm sending the hello as .100, but I'm unable to receive any hello from .200. So basically they are unable to send and receive the hello. They are unable to see each other. Unable to see each other over here. Might be there's an issue with the switch. So probably what I can do is I can stop the switch and let me go to those routers here and let me go to R4 and save the configurations here. Okay. Actually take a different switch. Might be the switch is creating an issue here. So let me like delete it off. And let's take something called as VIOS switch. Let me save the configuration for R1 and R2 here. You got the problem, right? You are sending the hello packets from .200. You should receive the hello packet from .100, right? You're sending the hello, but you're unable to see the hello from the other side. So both are sending the hellos locally, but they're unable to see the hellos from the neighbor. I've saved the configuration for R1 and R2. Let's do use space all for time being. Let me reconnect it back. Before that, I have to shut down these two bad boys. I have to go and just reconfigure the IPs to these three PCs over here. That's fine. But if I look back to my R4 or router as a host here, should be up in a moment. If I look into R1, should be up in a moment. Up here, okay, R4 is fine. Now, if I look at R1, can I ping my loopbacks outside, which is 1.1.1.1, should be reachable. So my default route is working fine here. Likewise, I can go to R2 and ping the loopbacks. My default router is working fine here. And if I go to R4, R4 can ping 192. Oh, my switch is off. Let me start the switch. Now I want R1. R1 says I'm active. R2 should say I'm standby. Switch is not yet up. Let's wait for that. It's up now. So if I go to R2, R2 is unable to ping .100. That's strange. Oh, now it's working fine. Switch is up. R1, if I look for now, I think it's good. Show standby. So I'm standby. So R1 is standby now. If I go to R2, it should be the active one. So show standby. Hey, very good. Very, very good. So what happened here is there was some issue with the switch. So I have just rectified that. And now you can see that R2, this particular outer R2, this interface E00, it became the active. And it knows that .100, it is a standby. Okay, and by default, everybody is having a priority value of 100. And the weight, the default value is 100 over here. Preemption is by default disabled. Okay, So at this stage, what happens is now R2 is active and R1 is a standby. Now these users, when they are sending the traffic now, when these users are going to send the traffic now, first of all, they will do an ARP for the default gateway. So for example, if I go to this particular router as a host, which is basically this one, I'd saved it, but might be it didn't save. Give it a sec. I'll just configure the IP back here. Okay. I'll just say here no IP routing. And I'll just say interface E0/1, no shut here. And your IP address is 192.168.1.1 as per the plan. And you have a default gateway. Go back, you have a default gateway which is set to 192.168.1.150. That's the virtual default gateway for you. I mean, the PC does not care, right? So now what happens is if I do something called as show ARP, and I can see that, this is my IP, my MAC. But if I try to ping my default gateway, let's say ping 192.168.1.150, first I will do an ARP to find out what is the MAC of this guy. And once I do again show ARP, I find that virtual MAC in my ARP cache for the default gateway. Looks interesting, right? So now who is active? So active is R2 and standby is R1. So with that in mind, I can ping, let us say my outside world, which is 1111, working great because I'm able to reach it. Superb. And if I do a trace route to see if I want to reach 1111, what is the path I'm taking? So the path will be through R2 because he's the active one. All right. Yeah, you can see that you're going via R2. Right? That is the path you're reaching, you're taking to reach the outside world. Okay. And then you are going via R4 this way. Now, what happens if this particular interface fails? If this E00 fails, then of course E00 of R1 will become the active, right? So if R2, let us say, go to R2, and I say that, hey, you failed, I can go and say interface, E00, you are shut down. If you fail, then what happens here is it will automatically change the state for 10 seconds, the protocol is down, the interface has failed. Now what will happen is it will become standby. If I do to standby here, you can see that it is in it. It is actually looking for that. You will set I go to R1. R1 has made the role as active, by the way, So if I do here show standby here, you can see that I'm the active now. Okay. And if you go back to the the end user and try to ping 1111, the ping works, should work. So lab scenario might be, the ARP cache is an issue, so clear ARP cache, and then you try to ping 192.168.1.150, let's say, just the labbing things, and then you try to reach 1111. Might be, R4 is not able to give a reply because might be R4 is choosing the path which is via. That's the reason I would like to have routing protocol in the mix here, rather default and static in the lab. So let's say I run a routing protocol to be just to make things simpler. So let's say I don't have the default route and all, so I say no IP route 0000. Okay. Likewise, I go to R2, I say no IP route 0000, just to make things simpler. I'm going to run a routing protocol here. And in the ISP router also, you have got no IP route, which is 192.168.1.0. Okay, so if I see here, show IP route on my ISP router, there is no static route here. I would run, let us say, my protocol, which is EIGRP. Let's say router EIGRP AS100, no auto summary. I won't advertise everything. So network, 1110. In EIGRP process, network 2 dot. In EIGRP process and network 14.110. in EIGRP process and 24. I'm just doing with the routing protocol here. Okay. And similarly, I'll go to R1. On R1, I'll say router EIGRP 100, no auto summary. Network is 192.168.1.0, which is basically my LAN network, and 14.110, my WAN. I'll have a neighborship with this guy now. Here we go. And on R2 also, I'll have router EIGRP with AF100, no auto summary. Network is 192.168.1.0. And network is 24.110. Now what happens here, it forms a neighborship here. Now if you see do show IP route specifically for EIGRP. Now through EIGRP, you know regarding the outside world. Okay, 1 and 2. Likewise on R1, if I see do show IP route EIGRP, through EIGRP, you know that outside world 1 and 2. And what happens with R4 is R4 would know through EIGRP my LAN network, which is show IP route EIGRP. It knows the LAN via the best path. Okay, so 14.111 is the best path through which it knows here. Okay, let's say choosing this particular path as the best path. But honestly speaking, it should also choose both the side as the best because I didn't change anything. Should choose actually both the path as the best. Okay, cool, that's fine. So the idea is, when you are trying to reach to the outside world, what happens is you saw that, right? You saw that that your should ping now. Yeah, it's working fine. So you saw that, whenever this interface loses it, it becomes standby, and the other one becomes from active to standby to active. Okay, so right now at this situation, what I have is I have R1. If I do show standby, so R1 is the active router. Okay, and if I look into R2, so R2 is basically my state designated, or basically it is a standby one. Okay, now by default preemption is disabled. So what are the extra commands you can type here? For example, you can just go to the interface, E0 bar 0, and you can say standby, group number is 1, give a question mark. These are the different commands that you can type, right? So you can actually go for authentication, say authentication as Cisco 123. So similarly, you have to go to R1 also and go to the interface and give the same authentication. Standby 1 authentication with the same password as Cisco 123. Okay. Likewise, what else you can type is standby 1, give a question mark. You can change the timers. You can change the MAC address. You can enable preemption. You can change priority if you want. So let's do that. I want to change, I want to enable preemption. So standby 1 preempt. Okay. Likewise, do the same thing on R2. Standby 1 preempt. The preemption is enabled here, which is a good idea. And let's change the timers. So standby 1 timers. Say by default, my first thing is the hello interval. I want to make it 1 second, and then that whole interval that is basically 3 seconds. Let's say I do that, right? 1 and 3. Same thing I have to do here as well, which is standby 1. Timers is 1 and 3 here. So I have enabled preemption, I've enabled authentication, I've enabled the timers, and let's say manually I want to make R1 as the active. Okay, so in that case, I want to configure a priority here. So I can say standby 1, I can say priority. So I want to make it, the range is between 0 to 255. Okay, so 0 is like not the best choice. So you can make it, let us say 150. Okay, so now if you just bring back the interface, let's say I go over to R2, and if I just say no shot to the particular interface, now since preemption is enabled, what happens is R1 will become the active now. Okay, because R1 has got the highest priority. R1 has the highest priority, so R1 should become the active now. Oh, that port was off actually. There's a reason R4 was not choosing 2 path as the best path. I think now it is fine. Yeah, looks good. So if you go back to R1 here, okay, so what are the commands you've typed? Just have a look into it. So show, run, interface E0/0. You can see for HSRP, you configured this is a physical interface IP address. That's a virtual IP for HSRP. There's a timers. That's your priority, which you configured as manually 150 because you wanted to make R1 as the active interface. Preemption is enabled right now. You've made that, and authentication is configured as Cisco 123. Okay, the same thing over here. So it should match, the configuration should match, between the routers in the group. So show run interface E0/0, and the commands are pretty same. Physical IP, the virtual IP here, timers, preemption, authentication. Good. So with that case, since R1 is having the highest priority here, and you didn't change the priority at R2, which is set as 100 by default. So at R1, what happens is if I see show IP, show standby, I can see that I'm active and my priority is 150. It's configured as 150, and the standby is .200, and whose priority is 100. I know that. I'm the active router. It's me. I'm the active router. Okay, so let's do a continuous ping here. So ping to, let us say, the internet with a repeat of, say, some big number of packets. It's happening. In the meantime, what happens, I go to R1 and I can say, hey, your interface went down. Your LAN interface went down. E00 shut down. And if I go back to the host here, the host might be hardly one packet was lost here. Look into that, a single dot. Here we go, that single dot. But no issues from the host side. It's still working fine. Okay, so R2, within 3 seconds of time, it should become active. So now R2 became active. If I do show standby here, R2 is active. And since preemption is enabled now, what happens is if the R1 interface, returns to its original state, I say no shut to R1 interface, it should regain the role as active now because preemption is enabled. Here we go. This became active. Okay, so if I do show standby back at R1, let's say do show standby back at R1, it regains the role as active. And what will happen to R2 is it will become standby. Okay, so preemption is a very good choice to work with. So next thing, what I want to explain in HSRP is your tracking. Okay, tracking. What's the meaning of tracking here? So let's understand that I have got here the LAN interface. So if this particular LAN interface, if it fails, okay, he's the active router and he is the standby router. If the LAN interface fails, I'm okay. I mean, then it can send a hello. It's going to receive a hello packet. So R2 as E0/0 will become active router. We know that, right? But let us say that's not the point here. Let's say what if he's active, he's a standby, and what if the uplink fails, right? If the LAN users are trying to reach here, so basically it will do a ARP for the default gateway, and whoever is the active router, it will be responsible for sending the ARP reply. So the traffic will go to R1. Okay, now R1 will actually not be able to send the traffic outside because the uplink is down, right? That is a big problem here. So HSRP is fine in the LAN, but the uplink of that active router, if it goes down, there is no issue that HSRP is going to take an effect by default, right? So what you want is this. So if, let us say, the active router uplink interface goes down, make sure that R1 should become standby and R2 should become active. Okay, that is called as tracking. So what I'm going to do is I'm going to track this particular uplink interface. I'm going to configure HSRP that, hey, please see the status of the uplink interface. If it is currently up, then use yourself as active. If it goes down, make sure you decrement your priority. You decrement your priority, let us say, by a value which is, say, 60. Okay, so your priority is right now at 150. 150 minus 60 becomes your 90, and this set priority is 100. So what happens is, since preemption is enabled, so what happens is this guy will become the new active and this guy will switch back to standby. Okay, so the whole idea is very important thing. So if, let us say, the active router uplink fails, you enable tracking here so that it will decrement the priority by a particular factor. Okay, and it should come below the other router's priority value, so it can check the state and attain the active role. Okay, that's called as tracking. So let's go and do that. So I'll go to R1. So R1 is currently active router, we know that. Okay, And let's say I go to interface, I go to my HSRP configuration. I go to interface E00. I go to standby 1. I should say track, give a question mark. You can actually track an object number. So here, before that, I have to actually create the track object number here. So I have to create a track object number, say 10 as an example. I can say interface, which is E0/1, and I can say line protocol. So basically, I made a track object number here as 10, and I'm tracking this particular interface E01, and I'm checking the status of the line protocol. Okay, so if I look for show track now, I can see that I've got track object number 10 created, and currently my interface E01 is getting tracked for the line protocol status, and currently my E0/1 is up. Okay, now what I'll do is I will call that particular track object in HSRP config. So I'll go inside E00. I'll say standby 1 track, then I'll call the object number, which is basically 10. Okay, and I should say if it goes any state changes, so decrement the priority by a factor of 60. That's it. Okay, so now at this particular stage, if you look, show standby, you can see that there's a track object which has been called for HSRP config, and currently the uplink is up. But if the uplink goes down, I would configure my priority to be decremented by a value of 60, which will make it 90. Okay, so at this stage, what is happening? The router, this user is trying to reach. The user is trying to reach, via the active routers, which is via the R1. So if I ping 1111, this traffic is going via the R1. Okay. Now, what if the uplink fails? So the uplink fails, then what happens is it will decrement the priority by, factor of 60. So if I go to R1 now, and if I see here, my uplink, which is interface E0/1, and it fails, let's say shutdown, and there will be an issue here. You can see that the track object says that, hey, my interface E0/1 is down now. And what happens for HSRP? HSRP becomes standby. Fantastic, right? So if I look for show standby, I can see that my priority became 90 because my track object is down. Okay, and I'm not the active, I'm standby. Okay, and who is the active? So if I go to R2, R2 is active now. Good. If I do show standby here, R2 is the active router now. Okay, and if I still go to this end host and try to ping, it still works, not a problem. If I do a trace route to reach 1111, I can see what path I'm taking now. I should go via R2. Okay. Here you can see I'm going via R2. So another important thing which I'm going to discuss is, HSRP multiple group load balancing. Let's discuss that. It's a very important topic. It's very industrial topic. So it is called as HSRP multiple group load balancing. What do you mean by that? Very simple. So let's say I want to keep something called as, let us say, 2 default gateways here. Okay, let's say these 2 users, the first 2 users are using a default gateway. Say it is 192.168.1.150. Okay, and so these 2 users are using the default gateway as 192.168.1.160. Imagine I've got organization in the same department, but I've got 2 users using the default gateway as .150 and 2 users using default gateway as .160. Okay, that means I should have 2 virtual IP here. That means I should have one more virtual IP sitting here as 192.168.1.160. Okay, now what I want is, I want that one router should be active for .150 as the virtual IP, and the other router should be active for .160 as the virtual IP. Right? So for example, I want that when my VPC 7, VPC 8, this user wants to go out, it should go out via R2 because he will be holding .160. Okay, and let's say I want this end host, this router as an end host, and if VPC 6 wants to go out, then R1 should be active for .150. Yeah, that's the way I should do it. So normally, how do I do that? Let me write down the commands for you so you understand that if you want to deploy it down the line. So I'll say, hey, at R1, I'll say to the global config mode, I'll go there and say standby, basically on the interface. So interface, which is E0/0, I'll go there and I'll say standby, say the group number is 11, whatever, okay. The IP is 192.168, 1.150. And I should say him that standby 11, your priority is say the highest, which is 150, okay. And I should say standby 11, you enable with preemption. That's a good feature, okay. Preemption is enabled. And also I can do tracking. So standby 11, I can call it track object over here, say track object number 10, right? And I can use that decrement factor by whatever, say, just for example, say 60. Okay. And what I can do is I can create on R1 another group, which is basically another group called a standby, which is say 22. Okay. And I can say the IP is 192.168.1.160. All right. And I can say standby 22 preempt. That's it. So what I've made is on R1, I made two groups for HSRP. One is 11, one is 22. For 11, the VIP is .150. For 22, the VIP is .160. And for group number 11, holding .150, I'm having the highest priority. Okay. So I'll be the active for the default gateway of .150. Similarly, on R2, what I'll do is this. I'll go to interface, which is basically E0/0 of R2. And then I'll say standby 11, IP is 192.168.1.150. And I'll just say standby 11, which is basically preempt. Okay, that's it. And what I'll do is I will go to this same router. I should say standby group number is 22. And I should say the IP is 192.168.1.160. And I want R2 should be the leader, or it should be the active router for HSRP. So I should say here that you hold the preemption. 22, you hold the preemption. Okay, and your priority is the highest. Say it is 150. Okay, and you can enable tracking here. So standby 22, say track, whatever track object number you create, let's say 10 for the uplink, and then you can decrement by a factor of 60. Okay, that's it. So with that in mind, what you can do is you can make, two routers to be part of HSRP, two groups, let's say 11 and 12. And, you can make like R1 to be the active router. So right now my condition is this. So R1 is the active router holding for default gateway 192.168.1.150. And it is the standby router for 192.168.1.160. Okay. On the other hand, R2 is the active router for 192.168.1.160, and he is a standby router for 192.168.1.150. Okay, that is a scenario what you can go for with HSRP, having different groups of load balancing. You can actually do with VLANs also. If you have two separate VLANs, VLAN 10, VLAN 20, you can also play with that down the line. But if you want, let us say in single VLAN, I've got, some users are using one as a default gateway, another IP as a default gateway by another users. In that case, I can actually group it in two separate logical entities. Yeah. So this is the concept of HSRP. This is the concept of tracking the links. This is the concept of how HSRP behaves. All right. So the next thing is all about VRRP. So as I've told you regarding VRRP, what it does, same concept, but the naming convention changes to master and backup. So when you enable VRRP on the LAN interface of this couple of routers or the group of routers, one of the router will be elected as the master based on, again, the highest priority. If the priority is tied, then whichever IP is the highest on the LAN interface, that becomes the master, and rest everybody is called as the backup routers. Okay, configuration wise, I mean, no big changes there, similar configuration. So you can just go to, both R1 and R2. Let's say I go to R1. On R1, what I'll do is I'll go to interface, E00, and I'll just go and say command starts with VRRP here. The command starts with VRRP with a group number. So group number is 1. Then give the virtual IP, which is 192.168.1.150. Then you enable, in case of VRRP, preemption is enabled by default, but yeah, if you want, you can enable that. That's not required, but as a case, matter of choice. Okay. Then you can define the priority of your choice. So VRRP 1, let us say you can define if R1 you want to make it as the highest priority. So you can define the priority as 150, let's say. And you can also call the tracking over here. So VRRP 1, you can call the track object number 10, and you can decrement by a factor of, let us say, 60, so that it can overtake the role if the uplink is down. And likewise, you can enable authentication. Okay, authentication. Say password is Cisco 123. Okay, in same case with R2, what we'll do with R2, you'll go to the again interface E00, and then we'll say VRRP1, configure the virtual IP as .150, and you can enable preemption. By default, preemption is enabled, that's fine. And rest, you can just enable authentication here. VRRP1, authentication as Cisco 123. Okay, same thing. So I just want to show you that, and let's go and configure this on R1 and R2. So what I'll do is I'll go to R1 and I'll remove HSRP from my configuration here. Okay, so I'll go to R1. I'm just going to remove that. Remove the configuration is very simple command. Go to the interface, which is interface E00, right? You give the command like standby 1. So just give the command, there's no standby 1, and that will remove HSRP from the interface. Likewise on R2, you go to the interface E0/0 and just say no standby 1 there, removing HSRP from both of them. Okay, so now if you just say show standby, and you will see the now output displays. That means HSRP is not configured, and we are not running with HSRP on both the routers. Now at R1 and R2, as per the plan, we'll go with VRRP here. So I'll go with interface E0/0. I'll say VRRP group ID is 1. I'll say IP 192.168.1.150, my virtual IP. If I want, I can enable preemption, but that's a choice. So I'm just going with priority first. So priority, I want to make this as 150. And I already have this, so I'll configure authentications, VRRP1 authentication, say it is Cisco 123. And I'll configure the tracking over here, VRRP1, track object number 10, decrement the value by 60. So leaving preemption, I configured all those things in R1. If you want to verify that, this command is show run interface E0/0. You can see what commands I've typed here. There's a physical IP of the port. That's my VRRP config with the virtual IP, priority, authentication, and the object tracking for the uplink interface. Likewise on R2, I'll go to R2, I'll just configure the same stuff. I'll go to interface E00, I'll just enable VRRP. So 192.168.1.150. And I'll enable authentication, because without that, you'll not be able to communicate, because you can see we have authentication here. So I'll say authentication, which is Cisco 123. If the password matches, they will communicate and he will become the backup router. So let's toggle the interface right now. So let's shut down the port and let's bring up with no shut. And it should become the backup here. Okay. So R2, if you look, command is show VRRP. So R2 says I'm the master. Okay, R1 show VRRP. Let's see. Okay. Oh, might be the uplink is down. R1 uplink is down, so its priority is 90 here. So what I'll do is I'll actually go and Let me go to my uplink E0/1. All right. If I do here show VRRP, so I'm the master because my priority is 150 over here. I'm the master. And if I look into R2, show VRRP, I'm the backup. Simple. Right? And if I go back to the end user here, so I try to ping 1111, no, not a problem here, right? I can reach anybody. And if state changes, so automatically what happens is, I can, the backup becomes the master becomes the backup, and the users don't have to worry about it. Okay, you will have the gateway IP still working as it is. Okay, so simple stuff I've told you regarding VRRP, how it operates in the theory. Let's go and talk about the last protocol, that is GLBP. Okay. Now GLBP, it works quite differently because it has got multiple things to explain in mind. So I just want to write down some few points about GLBP first. Okay, so let's write down some few points here for this protocol called as GLBP, and you can see key points for GLBP. So GLBP can use up to 4 gateways simultaneously. Okay, it will maintain one virtual IP, and each router has a virtual MAC. Okay, different routers, virtual MAC is sent in ARP response. Okay, for virtual IP, and we have 2 roles. One is called as AVG, that stands for Active Virtual Gateway, and we have another role which is called as AVF, stands for Active Virtual Forwarder. Okay, now the answer is, the meaning is AVG will assign the virtual MAC to all routers, which is called as AVF. Okay, and AVG will answer the ARP request for virtual IP address. Okay, there is an important point here, so we need to understand the concept behind the scene. So let's say that I have got some 4 routers. In GLBP you can have around 1024 routers in the single group, okay, for achieving gateway redundancy. And GLBP as a Cisco solution, as I've told you earlier, and it can offer true load balancing kind of stuff. So let's say that we have got some routers like that. So you've got, let us say, some 4 routers here. Just imagine I've got another router here, another router over here. So this is R3, and this is say R4. They're also connected to this particular things. So now when you enable GLBP on all these particular LAN ports, right? When you enable GLBP on this all particular LAN ports, what happens is one of the router will be elected as AVG. Say R1 interface became AVG plus Active Virtual Gateway. Now he himself will be also called as AVF. Okay, so in a single group I can have up to 4 AVF. So remaining everybody will be called as AVF on the interface, right? So this is an AVF. So all of them, right, will be AVF. Right? This is an AVF, this is an AVF, this is an AVF, right? So the role of AVF is to offer the gateway solution. So everybody will hold this as a virtual IP. Okay, now the role of AVF is to forward the traffic for the end users. So what happens is, let us say this first user, okay, wants to send traffic outside. So his traffic, let us say it has gone via let us say R2. His traffic will go via R2. Now For the first time, what happens is when this user will do an ARP request to find out the MAC address of the default gateway. So every interface will have a virtual MAC. Okay, so this interface, I mean, R1 interface has got a, let us say, VMAC number 1. Okay, R2 has, R3 has got a virtual MAC address number 2. It has got a virtual MAC address number 3. It has got a virtual MAC address number 4. Okay, so what happens is when any end host does an ARP request for the default gateway, the ARP response is given by AVG. So AVG will tell, okay, you want to know the default gateway's MAC address. So here we go. Take the MAC address as VM4. Okay, now when this user wants to send the traffic outside, his traffic will be sent via R2. Okay, and this MAC addresses, that is these virtual MAC addresses, are assigned by the AVG to all the AVF. Likewise, when the second user wants to go out, he will do an ARP for the default gateway. The ARP response is given by AVG. AVG will say, okay, you take VM3. Right? So this user traffic will be going via this router outside. Okay, likewise, when this guy and this guy does the ARP request for the default gateway, AVG will respond for the ARP request with the MAC address. Let's say he gave the MAC address as VM2, he gave the MAC address as VM1. So when they want to go outside, respectively, this router and this router will forward the traffic to each other. Okay, so that's a way, how this GLBP protocol works. So we have got two roles, AVG, AVF, to understand, and that is the reason it is called as, it supports true load balancing. So at any point of time, you have 4 routers in the group, which is active. Okay, and 4 routers will actively allow these users to send their traffic to the outside world, and like a true load balancing, the traffic will go out. And I've told you that it works on UDP port number 3222. It has got a hello time of 3 seconds, hold down time of 10 seconds. If you want to reduce that timer, you can do that. Right. And by the way, I mean, regarding AVG, so it's again the highest priority. So by default, the priority is 100. Whichever has got the highest priority, he'll become the AVG. Rest everybody will become the AVF. Okay, if not, then the priority is tied, then highest IP address becomes the AVG, and rest everybody becomes the AVF. And remember, very important thing is, you have in a group, up to 4 routers can be there in a group as AVF, and everybody else in the group will be called as secondary virtual forwarder, right? SVF, secondary virtual forwarder. Okay, so you've got 1024 router in the group, out of which 4 routers, including the AVG. So AVG can be AVF. So including the AVG, everybody is your active, and they are your AVF. Rest everybody in the group is your secondary virtual forwarder. Okay, so that's the concept. And AVG holds the important thing because it is going to respond for your ARP request now. Okay, now regarding configuration is very simple. So what you do is, I just want to write down the configuration steps here. Okay, so let's say you go to R1. You go to R1, you go inside interface Ethernet 00. The command starts with GLBP with the group number 1. Okay, you can say the virtual IP, which is 192.168.1.150. Okay, and then you can say GLBP 1 authentication, right? This is Cisco 123, and then you can configure preemption is by default disabled, so you can enable preemption here. Okay, and then you can define the timers if you want. GLBP 1 timers, which is say 1 second and 3 seconds as hello and hold. You can configure manual priority, say GLBP 1 priority as 150. Okay, that's it regarding tracking. I'll tell you how it is done. Hold on for that. So in case of R2, you will go inside interface E0/0, and then you will say GLBP1 IP as 192.168.1.150. Okay, then you will go and configure authentication, GLBP 1 authentication. It is same password. And then you will go and configure GLBP1 preemption. Good to enable that. Configure the same timers, which is 1 second and 3 seconds. Okay, that's it. So you enable this, correct? So once you go and enable this on R1 and R2, then of course you have one router as AVG, one router as, both the router will be AVF, including the AVG. Okay, so let's do that. Let's configure this. Okay, so let's remove VRRP from the picture here. So let's go to R1 and let's remove VRRP. So similar way, I have to go inside interface E00. I should say no VRRP1. Likewise, I have to go to R2. Inside E00, I should say no VRRP1. And then I should go to R1 and I should say the commands for GLBP. So starting with this, so it is like GLBP1 virtual IP 192.168.1.150. Okay, then GLBP1 authentication Cisco 123 authentication. Okay, might be it takes an MD5 stuff. Yeah, there we go. We define MD5, then we say Cisco 123. 1 second. It's key string, then Cisco 123. This is the changes here. So it's like, authentication, then we have got MD5 and key string Cisco 123. It supports encrypted authentication. That's a good thing. Then GLBP1, you can say preempt, and then you can say GLBP1, you can reduce the timers to 1 second and 3 seconds. You can say GLBP1 priority, say it is 150. That's it. You can come to R2 and configure the same stuff. You can go to interface E00, which I'm already inside it. And I can say GLBP1 IP 192.168.1.150. I can say GLBP1 authentication, MD5, e-string, Cisco 123, GLBP1, which is basically preempt, and the timers, which is 1 second and 3 seconds. Good. So I want to verify the configuration. So show run interface E0/0 will show you the GLBP configs there. Okay, and similarly, you will go to R1. You will say show GLBP1 or show GLBP, by the way, or 1 second, show run interface show run interface, which is E0/0 configurations over here. And now to verify the GLBP output, command is show GLBP. Okay, and it's quite a long output. So I'm in R1. So I have a note for that. So I'm in R1. In R1, you can see that it's running group number 1. State is active. So this is basically for the AVG, right? So I'm actually the active virtual gateway. I'm maintaining this virtual IP. I'm having now there are 2 forwarders over here, including me. So I've got forwarder 1. There are 2 forwarders you can see, right? And this is the MAC addresses given to both the forwarders. So myself, I have 1 MAC. This guy is having another MAC, right? Forwarder 1 state is active. Forwarder 2 state is listen. It's kind of that. Okay. So the whole idea is, both these routers are actually active, and both the AVF, both the AVF has got a weight value, which is weight value by default 100. Okay, since the weight value is by default 100, what happens is we have equal load balancing, right? Both are having equal weight value, so it is equally load balancing will be given. So now if you look into that, so let's go to my end host over here. So let's say one of the MAC addresses 1000, one of the MAC addresses 2000. Okay, let's go and do that. So here I can go and say that on my router, which is basically, let me go to this router as a host. From here, if I try to reach outside world, which is 1.1.1.1, I'll do an ARP. I'll do some issue with that. Let me clear the ARP cache. So clear, 1 second. Enable. Clear ARP cache. And if I see show IP ARP, okay. Clear ARP cache, show IP ARP. All right. So now if I ping, yeah, it's working. So if I do now show ARP, So I can see that I've got the MAC address as something, 0101, which is basically one of the MAC address, right? Out of both the routers. Now let's say if any other user is trying to go out. So let's say in my topology, I've got this VPC 6. If he's trying to go out, so IP 192.168.1.2 over here, slash 24, and the gateway is 192.168.1.150. Okay, if I use show IP here, good, .2.150, and if I try to ping, let us say 1.1.1.1, and it is going out, very good. Okay, and if I do show ARP here, and I can see I've got the ARP as, for my gateway 150, the ARP is 0102, which is the second routers, right? Second router. So this guy got the ARP as 0101, and this guy got the ARP as 0202. PC6 it is, okay. I do here again show ARP, Control C, Control X, Z. Some issue with the GPC. Anyway, you saw that, right? It was 0202. Yeah. All right. So with that in mind, I mean, it's clear, I hope. So it's kind of a low balancing situation that it offers. Okay. And you can do object tracking also, like the way you have done it with HSRP and, with case of VRRP, you can do object tracking as well. So I'm just skipping the object tracking part in this particular case. Okay. But if you want, you can just do it in that way. So for example, if I want to do tracking of my uplink, so if my uplink fails, then of course I should not claim that I'm the, AVG, right? Because AVG holds the responsibility of providing the ARP response, correct? In that case, what I can do is, if R1 is the AVG, I can track my uplink, okay? I can go and say that interface, E0/0, I can say GLBP1 command is waiting. Then you have got this track object which you call, which is track 10, and then you can decrement the value by say 60, right? So basically this is the command that you use. You can call it track number 10, which you already created, and you can call that in the GLBP configuration. You can decrement the value by factor. So in that case, what happens is R2 will have the role for AVG as well as the ABF. Okay, and it supports multiple load balancing mechanism. So you have got different types of load balancing that it can support. So GLBP load balancing algorithm, you can say. So what first is, by default, I mean, it is actually round robin. By default, it is like round robin, right? So each router MAC address is used, right? So it's kind of, it's like, all the routers MAC address will be used one at a time, right? Then we have got something called as host dependent. Host dependent, that means every host will be assigned a unique MAC address. So if R1 is willing to go out, okay, then he got the MAC address for R1. I mean, if this router is a host, if it's trying to go out, if he gets the MAC address for R1, then next time also we'll get the same MAC. Okay. Likewise for VPC6, VPC7, if they get the MAC address for R2, next time also you will get the same MAC to leave the traffic. Okay. And the third one is basically weighted load balancing. So you can configure something called as a weight factor. You can make this interface, say the default weight is 100, and let us say you want to make this with a weight of 200 and with a weight of 100 over here. So what happens is, since R1 is having double the weight value, so what happens is it will handle more number of user traffic as compared to R2, right? So the users will have more ARP responses with R1's MAC address, like kind of double the responses with R1's MAC address as compared to R2's MAC address. Okay. And to see that, I mean, you can always go and check that out. So you can go to the secure CRT and you can go to R1, and you can go inside E0/0, you can say GLBP1. GLBP1, you can say load balancing, give a question mark. And these are the three things. And by default is the round robin mechanism. If you want to change that, you can change that with that. Okay. All right. So I hope it is clear regarding the configurations of GLBP and the FHRP protocols.